What are the steps manufacturers need to improve their reverse logistics? I would answer with 3 steps. The first one is the collection disposal. So we need to answer the question how to collect the parts, machine modules from the final user. So today the OEMs have done a very good job in optimizing the sales network. So how to sell the product, how to provide the final product to the final customer. But now they need also to optimize the network on how to recover, how to collect that part that they sold a few years before from the final customer. And then how to correctly dispose the product considering hazard material evolution regulation along product life cycle. We saw that during the decades, regulation changed, evolved. And so what today it's dangerous, it's a dangerous material, few years ago it was not. So it's important to understand and to track what has been installed and where to be able to know how to collect it and where. Digital twin and real-time monitoring will enhance OEM to follow up asset situation and maintenance background to be able to understand what to collect, where to collect it and how. Then tools like Quintic can help to optimize operation on the field. Second step is the disassembly and recovery. So we need to answer the question how to disassemble the assembly. If we think about welding, clips or not removable connections, this connection deny dismantling operations. In this case, asset reusability can be compromised since part of the assembly has to be broken to allow disassembly operation. Hence, OEM needs to embed in the engineering mindset the notion of design to disassembly to be able to increase the reusability, reparability, and recyclability rate during ownership and end of life. Another question of the second part is how to recover close to 99% of raw material and funnel the material back into the loop. So by perfectly disassemble and split part assembly, it would be possible to sort different raw materials, increasing the recyclability rate. Some coatings, treatments would be avoided to increase the recyclability of raw material. Embedding design for sustainability into design for manufacturing engineering roles, it will optimize part recovery and reusage at the end of product life cycle, while optimizing manufacturing processes. The third step is quality. Here we need to answer the question, how to check the quality of the parts that we collected. Is the part still usable? These are tricky questions, but tools like Internet of Things, big data, artificial intelligence, simulation are fantastic tools that can help us to understand if the part is still usable or not. By tracking the asset performances all along its product life cycle, we can understand if the fatigue limit has been reached or not, and so identify if the part is still usable or not.